This certain question on simple pendulum has been repeated 7 times. Yes, 7 times in JAMB UTME. So who knows, you might probably come across something like this in your UTME examination. But in the next 2 to 4 minutes, we'll be answering the question. And it says that a simple pendulum of length 0.64 meters has a period of 2.4 seconds. The period of a simple pendulum of length 0.36 meter is dash. So for simple pendulum, you need to know this certain formula. T equals to 2 pi root L over G. Having known this, we need to know the relationship between T and L, and also T and G. T here represents the period, not time. T represents the period, and it has its unit to be seconds. The L here represents length, the unit is meter, and then we have G, which is acceleration due to gravity, and the unit is meter per second squared. So now let's get the relationship between T and L. This is the relationship. The period T is known to be directly proportional to the square root of L. T, it is directly proportional to L, and then T is inversely proportional to the square root of G. To easily know this, imagine we have A to be B over C. Then I want to know the connection. This means that A is directly proportional to B. But whenever you have denominator, then you are going to have it to be inversely proportional. Same thing with this. T is directly proportional to L because L is the numerator, and then G being the denominator, T will be inversely proportional to the square root of G. So now that we have these two things, what if you have 2 values for periods, then 2 values for length? What do we do here? In this case, we have T to be directly proportional to the square root of L. I can guess the constants now. I can have this to be T equals to K square root of L from our knowledge on direct derivation, that T equals to K. That is, this symbol will change to equal sign as well as the K, the square root of L. So let's get this K. K will be divided by L divided by L. So square root of L cancels square root of L. Then we have K to be T over square root of L. So if it's just one value, we have T to be what? We have K to be T over square root of L. But in case we have 2 values, just as we have in the question, this will now give us T1 over root L1 equals to T2 over root L2. Please take note of this. We have 2 things here now. Having known the connection between the period and the L, we have it to be T over square root of L. But we have 2 values. Then this will turn out to be T1 over root L1 equals to T2 over root L2. So let's answer the question. So from the question, the length is 0.64 meters and the period is 2.4 seconds. So I'm going to make this one to be L1, then this to be T1. The period of a simple pendulum, so we are looking for T2 now. The period of a simple pendulum, when the length is 0.36 meter, is dash. So we have L1, T1, T2, then L2. So what are we doing? Having known the connection between the period and the L, which is T1 over root L1. So we are applying this formula. So this will be T1 over root L1 equals to T2 over root L2. And what is T1? That is 2.4. What is L1? That is 0.64. What is T2? It is unknown. And then we have L2 to be 0.36. So this will give us 2.4 over, if you check the square root of 0.64, this will give us 0.8. Then T2, also the square root of 0.36 will give us 0.6. We have this to be 0.6. So what do you do next? You have to cross multiply. So if you cross multiply, 0.8 times T2 now give us 0.8 T2. Then equals to, we have 2.4 times 0.6, 2.4 multiplied by 0.6. Looking for T2, divide both sides by 0.8, 0.8. 0.8 cancels 0.8, so we have T2 to be 2.4 multiplied by 0.6 divided by 0.8. So if we do well to punch our calculator down, we are going to have our answer to be 1.8. 1.8 seconds. So that is the value for T2. Like I said, you need to know the connection between the period and the length. So having known that, we got this, and with this formula we're able to calculate the value for T2. I believe you all have enjoyed the video. Please do well to like, to share, and then to subscribe in case you haven't, for you to get more videos. Thank you very much.